In this video, we're going to talk about the relationship between arcs and chords when pairs of arcs are congruent and chords are congruent, and what that implies to the others. Let's take a look first at this circle that we have right here. Now there's a lot going on here, but it turns out there's only part of this circle that we care about. In particular, what we're going to use is the congruent statement right here. Notice how these two chords here, YX and also VW, have a little congruence mark. So I'm just going to mark those in green here. So these are the line segments that we're caring about. We're going to focus on these. Now, because those are congruent, kind of makes sense, not a surprise, but again, we can't just assume it. But it turns out that because we know that these two line segments are congruent, that also tells us that the arcs that correspond to those are also going to be congruent. In particular, the way we would say that is we would say that arc, and I'll do this colored, right? I'd say that arc YX, right? So YX, and again, I'm making an arc. See how I've got the little arc symbol over it. That arc is congruent to this arc VW. And again, we're not saying it's equal, we're saying it's congruent. Remember, because we're talking about things. So this VW, the arc, those are congruent, and we get to use one of our favorite if and only if statements. Now, we can write it as words, or we can just write it as a double arrow. So if you remember from before, if you see a double arrow, then this fact on the left implies the fact on the right's true, and vice versa. So those conditions imply each other. And again, let's now write the congruent statement for the line segments, which are the chords. Okay, so the chords, YX, and notice the letters are the same, but the symbol is going to be different. Right, so now I'm talking about YX as a line segment, in other words, a chord in this when it's part of a circle, is congruent to line segment VW. Okay, now that's the foundation for what this whole discussion is today, is that if you've got two arcs, right, and again, let's just make sure we're talking about this, right? These are our arcs, and these are our chords. Okay. Now, just as a reminder, just since we've got that symbol, again, the double arrow, I mentioned it earlier, we write that different ways. Sometimes we write it as a double arrow. Some people abbreviate it this way. They might say if and only if. If. I've always liked that one. Or we might even write it out in words. If and only if, right? So you could write it double arrow, if, or if and only if. Oops, actually, I goofed there. I got a little carried away with my F's there. We shouldn't have that extra F. Don't write that extra F there. I was having too much fun with my if and only if. Now, when you write it out, actually, you just say the F like that. This is the abbreviation for it. Okay, so now we know all this is happening. Now, I know there's a lot of writing here. You wouldn't normally write this much, but the basic point is we can say, look, this measure, now again, this is the measure because it's 73 degrees. Now, again, we are looking for the measure of VW, right? This 73 degrees here must be the same measure over here. Hence, this is 73 degrees. And hence our answer would be 73 degrees. Okay, those are congruent. Now, don't confuse this with arc length, right? Arc length is different. Arc length is when you're measuring the distance like in inches or miles or kilometers or anything like that. This is the degrees. Now, it's going to be a little more obvious in the next one, just as a reminder what the measure of an arc is versus the length of the arc, right? The measure of an arc is a degree, and that corresponds to the central angle, right? In this case, we're being just told the central angle. Now, this is just a really random coincidence that those happen to be the same number. So don't think it's always 73 degrees. For some reason, it just turned out that way. Now, in this case, we know this angle, VXW, right? VXW 73. Now, again, because it's the center of the circle, that means that this is 73 degrees. The measure of the arc is 73 degrees. Now, only because it's the center. See how there's an extra dot there? This right here, this angle, this is not necessarily 73. In fact, if it's not the center, it's probably not. I know it looks like it might be, but it's not quite 73 in this case. So just be a little careful there. Don't just assume because there happens to be an angle there that other angle. It's only 73 because it's the center. We'll learn later what would happen, like if the intersection is over here, for instance, on the circle itself. Okay, so we've got VW. Now let's just look at our congruence statements. Again, we've got this chord congruent to that chord, right? So in other words, this line segment congruent to that line segment. Hence, this arc, again, congruent to this arc. And we've got similar kind of thing where this arc 73 degrees because that arc 73 degrees, the center angle also 73 degrees. Now, while we're at it, let's just look at something really quick. This is kind of handy. Now, notice that these are all radii of a circle. When you have radii of a circle, they all are the same length too. So just to double check, we could think about this for a second and realize, hey, you know what? I've got a sides congruence statement here, don't I? Right? Now, I wouldn't say they're vertical angles, right? Because they're not vertical angles. But that's just kind of a cool thing there when you notice, hey, you know what? I could use the old side congruent triangles trick. Okay, so let's move on. Now, the next thing we're going to think about is we're going to go one step further. We might actually have to do some solving on some of these problems. Now, in particular, notice that, again, we've got a congruence statement, but this time the congruence statement isn't initially comparing the chords, in other words, the line segments. This time we're actually saying, look, the arcs are congruent. In other words, it can go either direction, right? That's the whole point of it being an if and only if statement. Maybe I'm starting with the arcs, maybe I'm starting with the chords, but either one gives me the other. That's why it's an if and only if. So either one will tell me that. So in this case, because I know that my arcs are congruent here, then that means these segments here are congruent as well. In other words, my chords, right? So I could say, look, this is congruent to that. And with that, I can write a nice congruent statement here, and I can solve this equation, right? So 16 equals 2a. Okay, so I've got 16 equals 2a. Well, hopefully we can do that one in our head, right? 2 times 8, so a equals 8. So sure enough, a would be 8 for this problem, okay? And I always do this just because it makes me feel happy, is anytime I can, I'm going to write the numbers back in here, right? 2a, well, let's see, 2 times 8 equals 16, right? 16 equals 16. Yep, it looks right. If you got a figure, use it. It always helps just to double check your work. All right, let's keep going. This one, a little trickier. Now, this time, we've got 75 as numbers. Now, be careful with these. Don't get bogged down in the numbers when all they're really telling you is just that they're congruent, right? In other words, I'm not going to use 75 to calculate. I just need to know, oh look, 75, 75. Therefore, congruent. I'm not calculating anything with those. Now I can jump down here. It's therefore, oh look, congruent. Everything's falling together. And so I'm going to write an equation. 4t plus 6 equals 18, right? 4t plus 6 equals 18. All right, so let's do some solving here. My 6. 4t equals 12. Divided by 4, t equals 3. Okay, and what's it asking? Okay, t equals 3. Be careful, because sometimes they're not asking for the variable. They might be asking for the length. So do double check what they're asking for. So I've got t equals 3 here. Now, just to be sure, I'm going to put this back in here, right? 4t plus 6. Okay, 4 times 3 plus 6. 12 plus 6, 12, 18. Hey, look at that, works. I'm happy. Yay, it worked. Okay, now let's think about what happens with different circles. Now, it turns out this works with different circles as well, but only if the circles are congruent. Be careful with this. It's easy to kind of just get sucked into this and assume it's always true. Just an extreme example. Here, two circles, clearly different sizes, right? These arc lengths here, these little red line segments, they're actually the same length. On my drawing, they were both 13 millimeters. Clearly, though, this arc is not congruent to that arc. Very different arcs, right? So don't just start blindly running forward and say, oh, yeah, as long as I've got congruent chords. No, sure, if you've got two circles, it works, but only if the circles are congruent. Okay, be careful. All right, so, but we do have congruent circles, so hey, we can use it. All right, so let's now take a look at what we have here. Now, in this case, notice what it's asking for. It's asking for EF. Now, EF is right here. It's this minor arc, right? Notice it even reminded us it's a minor arc, right? This over here, definitely not a minor arc, is it, right? I've got 287 going all the way around here. That would be my major arc. So I am going to have to do a little calculating. Remember, when you put together the minor and the major, it's going to equal 360. So this arc right here is going to be 360 degrees minus 287. Right? 360 minus 287, which is just 73 degrees. Okay, that's 73 degrees. Remember what we came up with, though, is that we know that this arc is congruent to this arc because this chord is congruent to this chord, hence 73 degrees and 73 degrees. All right? All right, so we got that one. Now, last one here, little harder. We're putting it all together. Two circles. Again, I'm double checking. Are they congruent? Oh yeah, good. Congruent circle. I'm not just kind of running off and assuming something here. Now again, this is one of those problems. Be careful with this. Realize that sometimes they give you a number just to show that they're congruent, not because you have to use it in any other way other than just showing they're congruent. Right? Sure, 28, 28. Great. Those are congruent. I mean, sometimes I even do this. I'll just kind of like scribble it out. Like, okay, I got it. Let me stop thinking about it. I don't want to get confused. All I need to know what's congruent. I've used it. I've done. It could have been 56 and 56, 2 and 2, right? Just that's all it was there for. Okay, now I've got this minor arc here, which is UT. That minor arc is going to be congruent to this minor arc, RQ. All right, I'm going to write that down. Okay, RQ is 5x minus 36 degrees. Okay, now, before we were setting some things equal, in this previous one back here, right, we were setting lengths equal. This time we're not so much setting them equal. It's a different kind of equation, is we're adding them up and showing that they equal 360, right? I'm not going to set 5x minus 36 equal to 17x because that's not true, 17x minus 44. What I am going to say, though, is, hey, if I add this minor arc plus this major arc, it's going to be 360. So my equation's a little more involved, but still straightforward. Right? 17x minus 44 plus 5x minus 36 equals 360, right? I'm going to combine like terms, so 17x, 5x, I've got 22x, negative 44 minus 36 is negative 80, equals 360. Okay, I got to add 80 to both sides, add 80, and I'm going to get 22x equals 440. Just divide both sides by 22. I know there's a lot of steps here. I'm going a little fast, right, because I already know what the answer is. Let's face it, I did this problem already. Kind of cheated here. But anyway, so yeah, I know it's x is 20. X is probably 20, right? It's a lot of steps, easy to mess up. do what I always recommend. Take your values, put them back in the picture, and make sure it makes sense, right? Here's 5x minus 36, okay? Well, that's 5 times 20 minus 36, right? 100 minus 36. It looks like this is 64 degrees. Now, remember, I put my degrees back in. Okay, so this is 64, and it kind of looks like I could believe it's 64. Again, can't assume it, but it's always encouraging when it looks like it's the right size. Let's put this one over here now, right? 17x minus 44. Okay, so I've got 17 instead of x. I got 20 minus 44. Okay, 17, right? So that becomes 340 minus 44. I've got 296 degrees. Hey, look, 296 and 64, sure enough, add those up. You've got yourself 360 degrees. I'm feeling pretty good that I got the right answer. Okay, now, let's be careful. Is it asking for the variable or the arc length? Okay, it just wants the variable. Again, double check that. Don't get, because sometimes they're going to flip it on you and they're going to say, what's the arc length, or even sometimes what's the chord length. So come back here. Here's what I wanted. I wanted the x equals 20 for my answer. And so there it goes. All right, awesome. So that's what we have for today. Again, just remember the key point for today is when you have congruent chords, you know that the arcs are congruent, and vice versa. Congruent chords results from congruent arcs, right? It goes back and forth. All right, well, we will see you next time.